Hello students, I am Professor Ambika Devi, Assistant Professor of Physics, Government First Grade College, Bidar. Today's video is related to session 33 of BSc 5th Sem, Solid State Physics course, which is prescribed in the colleges affiliated to Karnataka State, Gulbarga University, Kalburgi. Let us now begin with the session 33 of BSc 5th Sem Solid State Physics course, and the session is related to problems on paramagnetism. Let us take question number 1. We have here the question is the magnetic susceptibility of medium is 546 into 10 to the power minus 11. Calculate the permeability and relative permeability. Now this is the question we have. I will write data for this question. So given data is susceptibility of the medium is equal to 546 into 10 to the power minus 11. So students, here we have to calculate the permeability. That is the first question. Calculate the permeability. This is the first question which is asked in the problem. So students, permeability nothing but permeability is the measure of the resistance of a material against the formation of a magnetic field, and it is denoted by mu. See here, mu is given by this formula. Mu is equal to mu naught into 1 plus psi. All of us we know that mu naught is equal to 4 pi into 10 to the power minus 7, and psi value is given here 546 into 10 to the power minus 11. After substituting the value mu naught and susceptibility, we get the answer of mu. And this here second question is calculate the relative permeability. We know this relation. Relative permeability is the ratio of mu by mu naught. So mu value is calculated from the first question, and mu naught is 4.10 to the power minus 7. After substituting these two values in this equation or in this formula, we get the answer relative permeability, that is 546 into 10 to the power minus 11. Okay, next problem is the magnetic permeability of the substance is 5.2 into 10 to the power minus 3. Find the reactive permeability and magnetic susceptibility of the substance. See a student. Now this is the question which we have in front of us. Based on whatever given in this question, we would first writing the data, then we will solve the problem. Okay, so let us now start to solve this problem. First, given data are mu is equal to 5.2 into 10 to the power minus 3. Here we have to calculate a reactive permeability, that is given by the formula mu r equal to mu by mu naught. But then it is expressed as we know that mu r is also calculated by this formula 1 plus psi m. Okay, then psi m is equal to mu r minus 1. So substituting mu r value, we will get the answer of magnetic susceptibility. Magnetic susceptibility, that is here mu r reactive permeability is calculated by using this formula. That is mu r is equal to mu by mu naught. Mu is given here. Mu naught value is 4.210 to the power minus 7. After substituting these two values, we get the answer of reactive permeability. Then using this formula, psi is equal to mu r minus 1. Mu r is calculated by using this formula. So after substituting mu r value in this equation, we get the answer of magnetic susceptibility of the substance. That is 4136. Okay. The next question. A magnetizing force of 520 ampere per meter produces a magnetic flux density of zero point 0.2 Tesla in a ferromagnetic material. Find the permeability and susceptibility of the substance. So here given is magnetizing force, that is equal to 520 ampere per meter, and the magnetic flux density is equal to zero point 0.2 Tesla. Here we have to calculate permeability and susceptibility of the substance. So we know that formula to calculate the permeability of the substance is mu, according to the definition. Mu is equal to B by H, and susceptibility of the substance is that is modified from this formula by using mu is equal to mu naught into 1 plus psi. Psi is modified, and it is expressed as psi is equal to mu r minus 1. Substituting the values from the given data in these two formula, we get the answer, that is mu is equal to 3.84 into 10 to the power minus 4, and psi is equal to 1494. See here, permeability of the substance is given by mu is equal to B by H. Here flux density B is equal to 0.2, and magnetizing force H is equal to 520. 0.2 divided by 520. After substituting these two values, we get the answer 1.67 into 10 to the power minus 3 Tesla per ampere meter. Okay. Then susceptibility of the substance is given by mu is equal to mu naught into 1 plus psi. It is modified as psi is equal to mu r minus 1. Mu r is calculated by using the formula mu divided by mu naught. Here mu is equal to this one. Mu r is equal to 4.2 10 to the power minus 7. After substituting the values in this expression, lastly we get psi as 1494. Okay. The next question is, a bar magnet made of steel has a magnetic moment 1.5 ampere meter square and a mass of 2.6 into 10 to the power minus 3 kg. If the density of the steel is 9.2 into 10 to the power 3 kg per meter cube, find the intensity of magnetization of the magnet. So first we will write the given data. Here given data is magnetic moment. Magnetic moment of the steel is equal to 1.5 ampere meter square. Mass of the substance is 2.6 into 10 to the power minus 3 kg. Density of the steel is 9.2 into 10 to the power 3. Then here we have to calculate intensity of magnetization of the magnet. Formula to calculate intensity of the magnetization is, according to the definition, it is given by I is equal to m by v, where this v is the volume of the material and it is calculated by using this formula, that is v is equal to mass by density. See here, mass of the substance is given by 2.6 into 10 to the power minus 3 and density is 9.2 into 10 to the power 3. After substituting these two values, we get the volume of the material. Then this volume of the material is substituted in this equation. M value is given, V is calculated by using this formula. After substituting these two values in this equation, I is equal to M by V, we get the intensity of magnetization is 5.3 into 10 to the power 6 ampere per meter. Okay. Then next problem is an iron rod of length 0.6 meter has a cross-sectional area of 5 into 10 to the power minus 4 meter square. If the flux of a magnetic induction through the bar is 2 into 10 to the power minus 4 Weber, then and the relative permeability of the iron is 4000, then calculate the intensity of the magnetizing field. Here asked is intensity of the magnetized field. So here given data are flux is equal to 2 into 10 to the power minus 4 Weber, mu is equal to 4000, and area, cross-sectional area is 5 into 10 to the power minus 4 meter square. Then by using these data, flux density is calculated by using the formula flux density B is equal to 5 by A. So here flux density is calculated by using the formula phi by A. Here phi is 4 into 10 to the power 2 into 10 to the power minus 4 Weber, and cross-sectional area is 5 into 10 to the power minus 4. So we get the answer B is equal to 0.4 Tesla. Here asked is calculate the intensity of the magnetizing field. Intensity of the magnetizing field is calculated by using the formula H is equal to B by mu. Here mu naught is given, so this mu is expressed in terms of mu r and mu naught. So B divided by mu r, mu naught. Mu r is equal to relative permeability equal to 4.4 pi into 10 to the power minus 7, and this mu naught is 4000. After substituting these values, we get the answer H. The intensity of the magnetizing field is 79.56 ampere per meter. Okay, so thank you.